It is time to set our goals and introduce the framework we will use. Creating a machine learning algorithm ultimately means building a model that outputs correct information given that we've provided input data. For now, think of this model as a black box. We feed input and it delivers an output. For instance, we may want to create a model that predicts the weather tomorrow, given meteorological information for the past few days. The input we'll feed to the model could be metrics, such as temperature, humidity, and precipitation. The output we will obtain would be the weather forecast for tomorrow. Now, before we get comfortable and confident about the model's output, we must train the model. Training is a central concept in machine learning, as this is the process through which the model learns how to make sense of the input data. Once we have trained our model, we can simply feed it with data and obtain an output. Alright, the basic logic behind training an algorithm involves 4 ingredients: data, model, objective function, and an optimization algorithm. Let's explore each of them. First, we must prepare a certain amount of data to train with. Usually, this is historical data, which is readily available. Second, we need a model. The simplest model we can train is a linear model. In the weather forecast example, that would mean to find some coefficients, multiply each variable with them, and sum everything to get the output. As we will see later though, the linear model is just the tip of the iceberg. Stepping on the linear model, deep machine learning lets us create complicated non-linear models. They usually fit the data much better than a simple linear relationship. Awesome! The third ingredient is the objective function. So far, we took data, fed it to the model, and obtained an output. Of course, we want this output to be as close to reality as possible. That's where the objective function comes in. It estimates how correct the model's outputs are, on average. The entire machine learning framework boils down to optimizing this function. For example, if our function is measuring the prediction error of the model, we would want to minimize this error, or in other words, minimize the objective function. Okay, our final ingredient is the optimization algorithm. It consists of the mechanics through which we vary the parameters of the model to optimize the objective function. For instance, if our weather forecast model is weather tomorrow equals W1 times temperature plus W2 times humidity, the optimization algorithm may go through values like 1.05 times temperature plus 1.2 times humidity, or 1.05 times temperature minus 1.2 times humidity, or 1.04 times temperature minus 1.19 times humidity, and so on. W1 and W2 are the parameters that will change. For each set of parameters, we would calculate the objective function. Then, we would choose the model with the highest predictive power. How do we know which one is the best? Well, it would be the one with an optimal objective function, wouldn't it? Alright, great. Later, we'll reiterate what we've said here because there will be separate lessons for the ingredients of an algorithm. Did you notice we said 4 ingredients instead of saying 4 steps? This is intentional, as the machine learning process is iterative. We feed data into the model and compare the accuracy through the objective function. Then, we vary the model's parameters and repeat the operation. When we reach a point after which we can no longer optimize, or we don't need to, we would stop, since we would have found a good enough solution to our problem. In this section, we look at each of the basic building blocks in more detail. At the end, we will conclude by creating our first machine learning algorithm. Sounds exciting? Well, it definitely is. Thanks for watching.